are on problem 7. It says that Doug is pouring cement for his backyard patio that is 100 square feet. The cement comes out of the truck at a constant rate. It is very important that he gets all the cement poured before 12 noon when it gets too hot for the cement to be mixed properly. It is currently 11 a.m. and he has poured 75 square feet of concrete in the last 3 hours. At this rate, will he finish before noon? So we got to fill in the table here. Some of it's already filled in. So we know it shows us at where he is at 11 a.m., just like the problem said. And we have to fill in the rest of it. So we know that when 0 hours have passed, he has not poured any cement. So that's 0. So what we need to do is we need to take this and figure out our unit rate. Okay? So if we're going to take the total number of concrete poured, or the Y, and we're going to divide by the X, so that gives us 75 divided by 3, or a unit rate of 25 feet per hour. Okay? So if every hour he pours 25 square feet, after 1 he will be at 25. After 2 hours, 2 times 25 is 50. We have 3 is 75. After 4 hours, he will be at 100. Okay, so let's graph that. Remember, here's our x-axis, and it's hours passed, or time elapsed, and this is the amount of concrete poured. Okay, so here I'm just going to go by ones, and there's enough room for me to write my every single one in. Here, if you look at the numbers, you have to go to 100. So I'm going to go up by tens here. 10, 20, 30, 40, 50, 60, 70, 80, 90, and we make it to the top at 100. Okay, so let's plot our points. At 0, he hasn't poured anything. At 1, he has poured 25, which is halfway between the 20 and the 30. At 2, he has poured 50. At 3, he has poured 75, which is right here. And then at 4, he's all the way up to the tippy top 100. We can connect these because they're constant. So that's the graph. All right, let's go on to the next question, which might be on your next page. Okay, part C says, what is the unit rate for this relationship? And we already found that by taking your Y divided by your X. And Doug can pour 25 square feet of concrete per hour. Okay, so remember, it's your Y equals your unit rate times X. So which equation is, so unit rate times X. That's how you set these equations up always. So I have Y equals the unit rate times X. So this one works. Okay, now we're going to move on to E. Will he finish in time? Justify your answers. To me, I'm a visual person. So if we go back here and for every hour, see, this is 11, and 1 more hour puts him at noon. And if you look at the table, he's at that 100 square feet. So let's go back here. Yep, yes, he will. And he's going to have 100 square feet poured by noon. And I'm going to justify that by saying because he pours at a constant rate of 25 square feet per hour. Okay, moving right along. All right, so we're on a problem about Vanessa, and she is mixing formula for her baby. The graph is already done for you, and it gives the relationship between the ounces of water to the scoops of formula to make a bottle the right way. Is the graph proportional? And justify your answer. So I will tell you, in order to be proportional, you have to have these two things. One, the graph must go through the origin. And two, it must have a constant rate of change. Okay, so this one definitely goes through zero, but I want to show you something. If I make this little triangle here, it goes up by 3 over 1, and it continues to go up by 3 over 1. So my rate of change is 3 over 1, and it remains 3 over 1 the entire time. So yes, it is proportional. It goes through 0, goes through the origin, and has a constant rate of change. So what is the unit rate for this relationship? So we find the unit rate by the change in y over the change in x. And here it's 3 over 1. And if you divide that, it's 3 ounces of water for every scoop of formula. So 3 ounces of water, 1 ounce, 1 scoop of formula. Ounces are on this side, water's on this side, scoops are on the x. All right. C. At a different location on the graph, show and explain how you can find the unit rate. Okay, I kind of did that already, but I'll show you again. So I'm going to go right here. You find yourself a nice intersection and another nice intersection. So to get there, I have to go up 3. That's 3 ounces of water and over 1 to every scoop of formula. No matter where I find these intersections, if the rate is constant, that's still going to be the path you have to take. So write an equation um, to relate the ounces of water to the scoops of formula. Remember, I said y is equal to the unit rate times x. And we said our unit rate was 3. So I have y equals the unit rate times x. Y equals 3x. That is letter D. So how many scoops of formula, I'm on letter E, must Vanessa use to make a 9-ounce bottle? That's 9 ounces of liquid for her baby. So we can do this 2 ways. If you want to use the graph, we go over it here and look, and then we follow that over to where it hits and follow it down. That would be 3 scoops. We can also use the equation by plugging in our values. So we have y equals 3x. They're giving us the ounces, which is on the y-axis. So if I solve this problem to get x alone, I divide by 3, and x is 3. So there's another way. You can use the equation, or you can use the graph. All right, moving on to the last one. Ben, Boston, and Brighton have designed a remote control monster truck. They line them up to crush the mini cars in the driveway. The lines on the graph below show the distance in inches that each monster truck travels over time. So Brighton states that each truck is traveling at a constant rate. And is his statement correct? Why or why not? So if we look at the graph, Ben, he starts at 0, he goes 4 inches for every second. Let's see if it is the same. 1, 2, 3, 4 for every second. So Ben's constant. Let's look at Brighton. He goes up 1, 2, 3, 4 over 1, 2, 3. Let me get a different color pen for him. He goes up 1, 2, 3, 4, 1, 2, 3. Let's try again. 1, 2, 3, 4, 1, 2, 3. So Brighton, let's write the rates down. Brighton is 4 over 3. Ben is 1, 2, 4 over 1. And the last one, Boston. Let's give him a different color though. Let's go orange. Boston also starts at 0. He goes up 2 over 4 to the next point, up 2 over 4. So he's 2 over 4, which is equal to 1/2. Okay? So yes, they are. They are all at a constant rate. What do the values in the ordered pairs given represent? So let's look at this ordered pair on Ben's. I'm going to go back to black. All right, his Ben's is 1, 4. That means after 1 second, this is your X and that's your Y. Remember X, Y. So the X is time. After 1 second, Ben's car traveled 4 inches. This point means after 6 seconds, Brighton's car traveled 8 inches. On Boston's, it means after 4 seconds, Boston's car traveled 2. Okay, so let's find the unit rate for each of them. We already found Ben's up here. Ben is 4. Brighton's is 4 over 3. That's 1 1/3 inches per second. This is 4 inches per second. And Boston is 1/2 inch per second. So if you look at these, which one goes the farthest in 1 second? That would be Ben. He goes 4 each second. Ben's truck. Okay, let me write over here. Ben's truck. Okay? In this case, the higher the number, that means they go farther in the same period of time. These are just reviews. Let's review this together. Again, let's explain why the graph of a proportional relationship makes a straight line. That's because it has a constant rate of change. And the last point here is to summarize what you know about proportional relationships in the bulleted space below. So we know that they also have a constant rate of change. And their graph will be a straight line. And we know it must go through the origin. Okay, that's it for today.